All right, good morning, everybody. Sorry for the little bit of delay. I don't know if you can hear it, but there's like a hum in the background, and I've been trying to like track down the thing that's making that hum, and I cannot find it. One sec. That's gonna give you an echo. I'm just not gonna deal with the hum, and I'm gonna ignore it, and it'll be fine. Okay, so today, it's the last day. Oh my gosh, this has gone by so quickly. I was proofreading the email before it went out. I was like, oh man, it is day 5. You can't hear the hum? Excellent. Yeah, I guess it's just me though. I can hear it. It's something. It's something. My background's in linguistics and computational linguistics, but also phonetics, so I've had like that I'm not an audiophile, but I have been trained to listen very carefully. So if y'all can't hear it, that's fine though. All right, today. So yesterday we started working with categorical variables. So things where the thing that you're measuring is how many items or how many of your observations fall within different groups. And yesterday we did some graphing, so we did some plotting. And today we're actually going to ask questions about these differences statistically. So we're going to use the chi-square test. So the chi-square is kind of similar to a t-test, except instead of numerical data, we're going to be using categorical data. So instead of something like how many inches long is this apple, I guess. I don't know if people measure apples in inches. We're going to ask things like, what color is this apple? And what chi-square tells you is, with a certain degree of certainty, how likely it is. Well, it doesn't actually tell you that. So I'm trying to be like very specific and accurate in my use of language here. So it tells you how certain you can be that 2 sets of observations were drawn from different distributions. So my example here, which is apple-y, I guess because it's fall and it's apple season, and I'm in Seattle, which is in the heart of apple country. We might have red and green apples. Some of the apples are bruised, some are not. And we might wonder, is one of these colors of apples more likely to be bruised? And it won't necessarily tell us why such a relationship exists, but it will help us determine whether, with a certain degree of certainty, we can say that this is a robust difference, so that we think we'd be likely to see it again if we did another random sample of observations from these populations. So we're going to need a data set with at least 2 categorical variables in it. And I am going to use the same data set that I did yesterday. I have somebody's work here that I was just looking at. I really like this Seaborn color palette. I think it's super pretty. And if you made your kernels public over the last 5 days, I haven't gone in this morning yet, but I think I've been doing a pretty good job of going through and taking a look at everybody's and seeing what you guys are doing, and I'm very impressed. Everybody's doing amazing. Okay, so we're going to use this data set again. Oh, I haven't seen Anthony's. Oh yeah, because it was run while I was sleeping. I think that's fine. So we're going to start a new kernel. And do a notebook kernel, and just like always, it looks really great. Is it Ekenio? Ekenio? I don't know. I think there's some like options for how you could say that. I really liked your choice of color palette. I thought it was very pretty. All right. So just like the other days, we're going to start with R, and then we're going to go and do Python. And I'm going to copy and paste so that I don't misspell challenge, that's the real data science challenge, is nope. It's no. One of those days, man. The real data science challenge is spelling challenge right every time. There we go. And we're going to start with R. So the question that I have, and I've been thinking about it, and I think it might be useful in the future to do something like this, but, oh, you're getting buffering? One sec. I'll try something. Give me just a second, and hopefully that will nip this problem in the bud. All right. Let me know if you still see buffering. I do ask a lot of my internet connection. Oh, interesting. I guess because it happened. Interesting. So I switched the notebook to R, and then while it was getting ready, I clicked out of the notebook, and I still have the Python little thing, introductory, like boilerplate here. And you guys can get rid of this if you like. There's no reason to keep it in your kernels if you don't want it. If you do want it, you're free to keep it. But all right, so import our libraries. I think we're just going to need tidyverse because chi-square is base R, because R is a language for statistics and chi-square is a foundational statistical test. Oh, what I was saying is I think it might be interesting to do sort of a similar series to this one, but really focusing on asking statistical questions. Like, what questions can you ask statistically? How can you phrase it in such a way that you can get meaningful information out from a test? And like, what's the relationship between asking a question in language and then asking a question with statistics? I don't know, that might be interesting or useful. I don't know if people would be interested or not. Shrug. Read in our data. I'm gonna call this survey data. And read underscore CSV, and then our file is in input anonymous survey responses. And I think I actually did end up cleaning this one. So I'm gonna use actually, I think you can, if you're importing multiple libraries, import them like this. Yeah, you can. Okay, yeah, there is some interest in that. Okay. This is, I should say, for those of you who haven't been on Kaggle a super long time, this 5-day challenge is the first day we've done something like this. And we're not sort of sure, like, are people liking it? Is this useful? So there'll be a survey coming out, sort of to get your guys' feedback. Oh, I'd love to do an NLP one, Haps. I'd love to do an NLP one. That's my background. That is my bailiwick. Yeah, asking questions with stats. Awesome. Yeah, I'll pass that on. We'll see. If people want to like see if this is working and if people are interested in it. And then we also do want to clean the names because I can see, looking at where it's been read in, that there are spaces. Oh, excellent. I'm glad it is useful. Clean underscore, I think. Clean names. Error in clean names. Could not find function clean names. Maybe you can't read in multiple libraries at once. Well, you can't. I just discovered that. I'm pretty sure you may need to pass it in as a vector. I'm pretty sure I've seen people do it, but maybe it's only for installing libraries. Anyway, tangent, not important now. So I have a specific question that I am interested in. So this is, the data set is survey data for the survey that you guys had an option to fill out when you signed up for the challenge. So I'm interested in finding out whether if there's a relationship between having programming background and having taken statistics. So Haps asks, does percentage sign greater than percentage sign mean that survey data is passed in an argument to clean names? Yes. So this is called a pipe. It's an operator from the tidyverse. I think it's from Plier and dplyr, PLYR and dplyr, but Plier is now deprecated. So just dplyr. And what it does is it takes the output of a function, or you can also use it to pass a object, and then it uses that as the first argument of whatever the next thing is. So clean names, I think, has multiple arguments. So it will pass whatever data I get out of here and into here is the first argument. Hi, Galva. So let's see if clean names has multiple arguments, and I can sort of show you what I mean. No, it only has one argument, so that's not a that's a great example. Poorly named data frame as their example variable. Oh yeah, that's nice. So this is a library to read in Excel files, and this example takes in an Excel file and cleans the names. Yeah. All right. So I think that answered your question. And having taken statistics. So I have my question, which is not actually a question, so I shouldn't put a question mark after it. First, though, I'll need to read in my data. And the reason that I'm interested in this is just sort of, I mean, I've done some analysis on this data set previously to sort of guide the curriculum that I was developing, so that it was sort of like at a level where I think it would be useful for more people. But the thing that I'm sort of interested in is a lot of people who are taking this challenge already have some programming background, and most people already have some statistics background. So my hypothesis is maybe people have a statistics background but not a lot of programming, or a programming background but not a lot of statistics. So they're trying to sort of like beef up on the other thing, because for data science you do need both. I don't know if you guys have seen those like data science Venn diagrams where like it's a series of like awful pictures of the ways that different things interact. It's sort of a not very funny meme. All right, so now we can use a chi-square, and chi is in the email. Make it bigger. This big X. It's an uppercase Greek letter X, which is called chi. Now we can use a chi-square test to see if the proportion of responses across the two questions. What were the questions? Have you ever taken a course in statistics? Oh, nope, I did not actually copy that after I highlighted it. And do you have any previous experience with programming? Are different from chance. Yeah. So the sort of like the null hypothesis here is that it's just sort of randomly distributed across all of the options, and then we can reject the null if there is the responses are differently distributed than they would be if we just sort of like averaged out over each of the rows. I don't know. Hopefully that makes sense. I'm using my hands a lot and you guys can't see that, which is a little bit unfortunate. All right. So we're going to use this chi-square.test function. And what it needs is a numeric vector or matrix. So it wants count data, or it can be a factor. And then x needs to be a numeric vector or a factor of the same length. So what I'm going to do is I'm going to pass the two columns from my data frame, because those are both factors, in as x and y, if that makes sense. You do have to sort of like know what you're doing before you, in order to read the documentation, a lot of times you have to sort of know what all the specific programming words are, and I know that can be a little bit frustrating. But these are factors. Actually, I don't think they are. I think I need to read strings in as factors. Read strings as factors? Okay, so I'm going to have to cast these as factors, I think. Let's see if it works without that. So right now these are just columns of characters, but it doesn't necessarily know that when it sees the same response multiple times, that those are instances of the same response. It might think that those just sort of arose by chance because people could have put anything in there. So let's see if this works. Survey data, and we are interested in the statistics question, and survey data, and we are interested in the programming question. So a lot of times R will do a lot of like tidying and niceningness under the hood, and this may or may not be one of the times it does that. Oh, no, yeah, it worked. Excellent. So we see here the output. So Pearson's of the Pearson's chi-square test is also Pearson's of the Pearson's R test for correlation. They're sort of similar under the hood. He got around. And we can see some output here. So let me explain what that is. A little markdown cell below. Oh, I already had a markdown cell. Oh, well. X squared is the chi-square square SQUARED value. Bigger equals more difference from a uniform random distribution. No, it's specifically from the expected distribution, which it's assuming is a uniform random distribution, but it may not be. So let me be a little more precise there. Expected distribution. DF is the degrees of freedom used in calculating the p-value, and the p-value is the likelihood, probability, I always get those two backwards, probability that we would see a difference this large by chance if our samples were actually drawn from the same distribution. So Haps asks, is there any problem with switching the expected distribution? Nope. Nope. So you can imagine so let's say that you are looking at whether or not a specific dorm building has more men or more women in it, right? So you might have an expected distribution of 50-50 for men and women in the population. I mean, roughly 50-50. Let's say 48-48. And you might use that as your expected distribution, but if, say, you were at a college that was historically a girls' college, so there are more women than men in the student body population, you might set your expected distribution to be whatever, I don't know, 70-28 or whatever it is in the school as a whole, to see if there's a difference in this dorm between what you'd expect if you were just randomly drawing a sample from the school, if that makes sense. But I don't necessarily have a reason a priori to think that there's going to be a relationship between here. Also, I'm pretty sure that's not how you spell distribution, but whatever. If I set my p value to my alpha, the upper bound of the p-value that it would take to convince me that there wasn't no difference between the two groups to 0.05, I would find, so if I had set, I should say, you're supposed to set your alpha before you get going. I would find this to be convincing evidence that there might be be a relationship between having taken a statistics course and having programming experience. Yes, I in particular struggle to spell on account of being dyslexic. Oh, well, in that case, I am very impressed because I'm also not great in spelling in my second language, which is French. Or, in fact, I guess my primary second language these days is American Sign Language, and I'm also not great at spelling in American Sign Language because actually, so spelling using your hands is part of the language, and I am uniquely bad at it. Yeah. All right, so that is the chi-square test in R. Any questions about this before we move on to Python? I think I said that the extra credit was to visualize it. Yeah. I can do that in 6 minutes, no problem. Let's quickly visualize. Close enough. I know with the S and with the Z are from sort of like UK English versus American English, and I can never remember which is which. Let's quickly visualize this difference. And, oh, nope, I still want that to be marked down, but I do want another cell below it that is in code. So let's, yeah, so I'm just trying to imagine the plot that I want to make in my head. So that's sort of like how I get started with the plot is that I will imagine what I want it to be first, and then I do the plotting itself. She says Z for US and S for UK. Thank you. Yeah, I did it the US way. Excellent. I'm also far enough north and know enough Canadians that I see like a fair amount of Canadian English. And actually, I have a Google Home, and I set the language to Canadian English because I was interested to see if they would show the Canadian vowel shift in the voice, which is an ongoing vowel shift in Canada. And it just changed everything to metric. It did not actually change the voice at all, which I was very upset about. But all right, and then the aesthetic. I think let's actually just let's say X is Peter says, I love my Google Home, teach it machine learning. I think that's the idea. They just implemented reminders, which, thank God, I use reminders for everything, and being able to set them just like while I'm in the kitchen doing stuff is very helpful. Let's see, have you ever taken a course in statistics? It's a very transparent variable name, but it's a little bit long. And then let's try geombar. Yep, okay, and then I want sort of like a two-dimensional bar plot is what I want. And I have 3 minutes to do it in. Clock is ticking. Oh, actually, visualization zoo. Let's see. I really like, I don't know if you guys have used this before. This is not, that's not it. Actually, I may have, I think I linked to it yesterday, but it's a really good resource if I can find it. Too far back. One click. Let's see. Is it Data Science Central? Is it this one? ACM. Okay. and I know I'm scrolling super, super quick, but I'm just sort of like looking for something that will work for this data. I guess I could do a mosaic plot, but that's not ideal. Meh. See, picking visualizations is also like a good part of data science. So let's actually do color as whether you have any previous programming experience. And let's see what that does. So it may do... all right, that's awful to read with my eyes. Position equals, so what I think I want, Peter asks for the URL, for the visualization, this one, show thing, yeah, I think I want them to be next to each other. Yeah, so the argument is definitely called position. You know what I'm going to do? I'm going to look up the documentation real quick. geom bar. And then position adjustment either is a string or the result of a call to the position adjusting blah, blah, blah. Let's see. Okay, so the default is that the position is stacked. Let's try geom bar, ggplot, position dodge. That's the one. That's the one I want. I didn't even need to finish my query. And I believe that this is a text string, so it needs to be in quotes. Yeah, okay, that's less bad to look at with my eyes. It's still not great. So instead of color, let's actually do fill. So color is the border around the outside, and fill is the color of the actual bar. Okay, that's better to read. It's not, again, the best thing I've ever seen with my eyes, but I also have no time left. France saying, hi. So Francining. France says Phil is better to read, and I definitely agree. Okay, so let's move on to Python so I don't shortchange it. So just sort of looking at the data. Interesting. So it looks like a lot of the difference is coming from these people who have quite a bit of experience, who have taken a Python, who have taken a course in statistics as well. And people who only have a little bit of experience in programming are likely to have taken a statistics course at some point in the past. Interesting. Oh, it's Italian. That makes sense. All right, now let's do Python. Oh, actually, one sec. Let me first publish and then make this public so you guys can get added if you're interested. And I will say, just an apology. So yesterday I posted the notebooks for day 4 in the forum, and I forgot to make one of them public, and somebody let me know. So thank you for that. All right, make public. All right. No, I do want to make it public. I'm clicking on it. There we go. So now we're going to do the exact same thing in Python. Probably not the exact same thing, because if I've learned anything from doing this challenge, it's that Python is much harder for me than R. No, yeah, so Hap says, I think the names of the columns are to blame for the weird shape. Absolutely, they are way too long. So on the same notebook, I did another kernel just because for my own edification, and I did an alluvial diagram. Oh, so sorry. Yes. So Peter asks me to go slow when getting the data sets. So this data set is the 5-day data challenge sign-up survey responses. And you should be able to get it if you do just like 5-day data sets. Yeah, it's the second result if you ask specifically for 5-day in data sets. And Hap says the names of the columns are to blame for the weird shape. Yes, absolutely. In a different notebook, this one actually, I end up renaming all the columns so that they, and also all of the variables so that they look better and are more good to look at with your eyes. So if you're interested, you can check out that for how to rename columns and how to rename variables. Excellent. So Peter has got the data. Excellent. All right, Python. My favorite. It's good. It's good. I've learned a lot. Like I do actually use Python a fair amount, but never for visualization. Never, ever, ever. So this has been a good stretching of my Python muscles. All right, so we're going to import pandas, and we're also going to import scipy.stats. Oh, I saw that SciPy is actually officially launched after 17 years or something this week. So happy birthday, SciPy. All right, and when I'm done, I'm just going to go back to my R notebook and copy and paste all my narration so I don't have to go back and do it again by hand. So Peter asks, what do I use Python for? So I use Python a lot for data cleaning, actually. So a lot of my data cleaning pipelines. So if I have something that says it's XML that actually isn't XML, and I end up needing to use regular expressions for, which has happened to me more than once, I will do that in Python. I do a lot of NLP stuff in Python, so I use NLTK and I use Spacey for Python, which are both Python packages. But yeah, I would never visualize in Python. I will export data from Python and then import it into R to make my pretty plots any day of the week. All right, statistics, data frames. We're gonna import our libraries. I don't know how many times in my life I've typed import our libraries in a comment above me importing libraries, but it's been a minute. I've done it quite a bit. And you know what? I'm still gonna keep doing it. Commenting is important, y'all. Read in our data. I think we called it survey data in the last notebook, so let's do that again. A note, pd.read underscore CSV and dot input folder, and then that CSV. All right, that all worked good. And now we need to actually do the chi-square test. I don't need all these tabs. So we're going to use the chi-square function, and let's look at the documentation. So what does it want? So R would take in just a columns of a data frame, and it looks like SciPy actually wants an array of observed frequencies. So you can see that I was talking about how it's the difference between the expected and observed. So we can give it the observed frequencies as an array, and then the expected frequencies as an array, and it's optional. It wants a frequency column. Awesome, thank you, Haps. By default, the categories are assumed to be equally likely, so drawn from a uniform random distribution. Yes, this test is invalid when your values are very small. That's true. You do want to generally use a bigger thing. All right, we're gonna give this a try. So one thing that I'm a little bit concerned about is that. Okay, this is a one-way chi-square test. So I want to do a two-way chi-square test because I'm looking at two variables, right? So I was looking at the whether you have a statistics background and whether you have taken stats class. So let's start out by doing the one way, and then we're gonna do the two way. And Hap says, oh, the video's gone. Ooh, that's not good. Are you guys still seeing it? So Hap says, they are assumed to be the uniform distributed if no expected distribution is fed. Yes, yes. So if you don't give it anything, it'll just assume the uniform. Okay, so it sounds like it's just Peter, unfortunately. Maybe try reloading. And the recording will also be available. And I need to remember today, let me make a note, to download all the recordings so we can have them in perpetuity. Download videos. All right. Well, I will say what I'm doing, and hopefully you can follow along. Restart. Okay. But we will see you in a bit when you get back, Peter. All right. So first, let's do a one-way chi-squared test for stats background. I guess I didn't ask about, okay, somebody else has it frozen now. I've done all the things that I usually do to help with this. It's back on? Okay. Well, fingers crossed we can get through this. Just come on, internet. 20 more minutes. 20 more minutes. All right, and it's good for Peter now. Excellent. So we're gonna look in the scipy.stats package, and we want the chi-square. Oh, was it? Yeah, just chi-square. Test, and then we're going to, and Haps very helpfully told us the way to get the frequency table, which is within the data frame, we're going to ask for a specific column. I don't remember what any of these were called. Let's check out. So one thing that I will do when I have forgotten the name of things is just read in the head really quickly so I can see what they were called. Have you ever probably capital H, yeah, and then dot value underscore count. Okay, that didn't work. I've done something wrong. Series object has no attribute value count. Maybe it's values count. Series object has no attribute values count. You can also get the column by df.column. Good to know. I'm wondering how well that will work since I have spaces in my name. I'm pretty sure it will not work. Value counts. There was an S. I was just wrong about where it was. Thank you, guys. Value counts, and it's a function, so it needs parentheses at the end. Yes, excellent. Power divergence results. Let me add a little narration cell down here so I can explain what this output means. I think one of the most frustrating things about trying to do statistical tests if you don't have a lot of background is they just give you a lot of information, and it's like, what does that mean? Statistic here is the chi-square value, more larger equals more difference from from a uniform distribution, and p-value is the p-value, which is very low here, which is expected because most people had a statistics background and it wasn't just evenly distributed across the possible categories. So let's do the same thing, but for our markdown. Nope. I did not actually want it to be marked down, even though I clicked on it. I wanted it to be, for programming background, a code cell. All right, and it is, do you have any previous programming experience? And again, we can see, so this, this value is in scientific notation, so it means it's this number here followed by, with 24 zeros in front of it. So that's very small, and this number here, and this, the p-value here is this number with 195 zeros in front of it, or maybe 194. Anyway, many zeros. So this is also very, very small. So there, it looks like oh, Hafsaz has sent me a link to the two-way test. That is, in fact, exactly what I was going to look up next. Thank you. We're not randomly drawing from a standard, a uniform distribution of people where an even amount of people have taken a statistics course, not taken a statistics course, and taken a statistics course but forgot everything. And it looks like we're also not drawing from a uniform distribution of people who have none, a little bit, quite a bit, and quite a lot of programming experience. Which is not surprising, right? Like, who's going to be interested in data science? People who know what data science is and that have a little bit of background. So I'm not very surprised to learn this, but it is, you know, it's interesting and useful. All right. Now, let's do a two-way chi-square test. Is there a relationship between programming background and stats background? All right, so the function that we need for this is scipy.stats.chi2 underscore contingency. So chi-square test of independence of variables in a contingency table. Sorry, I'm trying to, so Sleepy John says, so I'm an exception. Scroll up. I'm not entirely sure what you mean, Sleepy John, sorry. So the function computes the chi-square statistic and p-value for the hypothesis test of independence of the observed frequencies. So the question that we're asking here is the one that I've written in text. Is there a relationship? So is it not that you're just sort of drawing two random samples and there's no dependence between them, statistical dependence between them? And then if we reject that, we can say, well, maybe there is a relationship between them, you know? Which, I mean, based on the fact that we just did this in R and we did find a relationship, I'm pretty sure there is a relationship. All right. So, no, I don't actually want to compute the degrees of freedom. Okay, so there's just so this is how the degrees of freedom are computed. Okay, I don't care about that. So we need to make a contingency table. So Sleepy John says, so I'm an exception. I'm from the programmer distribution who knows almost nothing of stats, but a lot of programming. I think that there's a fair number of people who are like that. Actually, what time is it? Yeah, we're almost done with this. Let's super duper quickly. Look at this alluvial diagram. I'm also very proud of it, so I am happy to talk about it. What am I looking for? Day 5. Nope, 5 day. 5 day in data. There we go. And then it's this one, and we're going to scroll down to the end once it loads. And scroll out a tiny bit so you can see the whole thing. So this shows the relationship between the three different questions. So people who have no programming background, but quite a lot of statistics but quite a lot of programming background are definitely in the minority. So it looks like also most people who have a statistics background and haven't forgotten it have some programming experience. Yeah, so the way that you read this is that you sort of follow one of these little rivers from question to question. And it's also a good way of seeing, because these bars are proportional to the count of people. It's a nice data visualization. I like it. And I did do this in R, because R is a good language for visualizing, y'all. Okay, contingency table. What's up? Is this the one I was... Oh, okay. I see what the problem is. I was confused because I had done this head column and I didn't remember doing it. So Plunky says, I have no programming and no stats background. I was thinking that a lot of people who came to do this would be in that camp, and there really weren't that many people. But hopefully you can still follow along and get stuff out of this. So good job sticking with it. Oh, thanks guys. I'm glad you liked my graph. I'm very proud of it. Oh, I don't know. So Anikio asked if we can do that graph in Python. Wow, I don't want to. Maybe. I am gonna stream this afternoon, but what I was planning on doing is there's an authorship identification competition, and I was planning on making a competition submission in the stream. So maybe next week. Oh, I seriously don't want to though. Maybe. I'm gonna put a big old maybe next to that one. All right, 2a chi-square. Contingency table. And I believe, Haps very helpfully, I'm gonna copy and paste this code, sent us contingency table, a little example code snippet. So, pd.crosstab. So it looks like in pandas, so just to sort of, this isn't gonna work when I run it because that's not what anything's called, but just to sort of run through what I see when I look at this. So in the package pandas, which I have aliased as PD because that's what everybody does, there is a function crosstab that I'm guessing cross-tabulates, that takes a column, two columns, column 1 and column 2 from a data frame. And I'm assuming these have to be the same length. So we actually have already done... Nope, I want to copy not paste. So we've already done getting both of those columns when we did each of these chi-square tests independently. So we can do this. So this should get us a contingency table. So let's run that and take a gander at it. Contingency table. So the row headings, this row here is the answers to this first question, and then these rows, this column is the answers to this question, so you can see the distribution. So only one person has no statistics background but a whole lot of programming experience. Only one person has a statistics background and also a whole lot of programming experience. Also, maybe they're already a data scientist. I always stream at 4 to 5 Pacific on Fridays. I do some sort of analysis, so it's a good way to get a hold of me. Although I feel like I get better internet in the morning because people aren't coming home on Fridays and watching Netflix, especially today since Stranger Things just came out, but we'll see. All right. So that is exactly what I expect a contingency table to look like, so A+. And now I want to feed this into this scipy.status.chi2_contingency, and I want to give it my contingency table. Well, that did nothing. So, Oh, okay, so maybe this is the output. So I'm guessing this is the chi-square, this is the p-value, and this is the degrees of freedom. Yeah, Galva, my Twitter has been all like, Stranger Things, Stranger Things, Stranger Things. 8 p.m. is not too late. Yeah, that's what I'm, so Hap says the second value is the p-value. Yeah, that's what I'm getting. This is much less helpful output than R gives you. I'm just saying, that's what I'm noticing with my eyes. Here, the first value, 16.827 is the chi-squared value. The second value, 0.0312, let's keep our significant digits consistent, is the p-value, and the third value, 8 is the degrees of freedom. So Haps agrees that the output is just not as helpful as it is in R, and that makes sense, right? R is good for two things. It is good for data visualization, and it is good for statistics, and like that's what it was designed for, and it does them real good, I think. Oh yeah, good point. So so Haps points out that I can actually use a little bit of LaTeX. And do chi-squared in the markdown cell. Yep, very fancy. But, important caveat in the last 5 minutes, because we have performed 3 tests of statistical significance. Significance. Close enough. So Pelunky asks, so the lower the first value is, the better it is for the test. Oh, so chi-square? No, you want chi-square to be bigger. So chi-square is the difference between the observed values and the expected values, and if you want to find a difference, the bigger that value is, the more of a difference there is, and then you get the p-value depending on the chi-square value, and then also that. So it is, so Peter says, I'm guessing 0.03 isn't significant. So it isn't significant at an alpha of 0.01. If you set that ahead of time and you're like, you know what, I'm willing to be wrong 1 in 100 times. But if it's ahead of time you set your alpha to 20 as to 0.05, and you're like, you know what, I'm willing to be wrong 1 in 20 times. In that case, it would be significant. So you can sort of think of this as if you say a difference, that there is a difference, how many times, I guess in this case, how many times out of 100 are you willing to be wrong? But this is a special exception here, because this is the third time we've done a significance test. So we did one here on the contingency table, we did one here on just this column, and then we did another one here on just this column. And because every time you do a significance test, you increase the probability that you're going to, by chance, just randomly get one wrong, you need to actually you need to correct for the fact that you are doing multiple tests. So Hap says, I think nobody sets alpha ahead of time except for medical trials. You should. In my field, linguistics, usually because we're working with smaller sample sizes, usually it's 0.05. And psychology, especially if you have a very large sample size, usually people will set it to 0.01. And for medical stuff, people will set it even lower because they're much less willing to be wrong. yeah, there's a big discussion in the science community about how to use p-values and when they're useful, and are people relying on them too much. Yeah. So I don't want to get too deep into that because it's it's a little contentious. But the way I see statistical tests are, they're a way to help build your argumentation. They're not going to tell you the answer, but they're going to provide you with a piece of evidence that you can use in the story that you're telling, right? So science is really storytelling and taking your the amount of uncertainty that you have about the world and reducing it. Okay, so we need to correct for the fact that there's a that the probability that we're going to get a significant effect just by chance increases with each test. If you set your alpha to 0.05, you'll be wrong just by chance 1 out of 20 times. So if you perform 20 tests, you're very likely to get the wrong answer on one of them, and you need to correct for that. We can do this using Cohen's alpha. I'm pretty sure that's what it's called. Cohen's alpha, yeah. Oh, no, Cronbach's alpha. No, Cohen's alpha? Multiple tests. Nope. Tests. Cronbach's alpha is a function of the number of items in a test. Anyway, so the idea is we can do this by multiplying our alpha by x, where x is the number of tests we have performed. I've forgotten the name of this test. I should have written it down. Well, I also wasn't expecting to do multiple comparisons today, but oh well. All right. So in this case, our p-value would have to be below a value of 0.5 times 3. This is not hard math, y'all. 0.5 times 3. Nope, divided by 0.016. Dividing our alpha by x to have an overall alpha of 0.05. So TLDR, because we did 3 tests, this final result is not significant at alpha equals 0.05. All right, hopefully that wasn't too much math just on the tail end of the stream. Oh, and let me actually publish this and make it public. Yeah, so I think that's gonna be pretty much it, guys. It's been a really fun 5 days. I really enjoyed it. I hope you guys learned a lot. I certainly learned a lot, mostly about Python. And yeah, thanks for joining me. And you'll be getting a survey in your email in either today or tomorrow at some point, just asking you for your, did you like this? What was helpful? What wasn't helpful, to sort of help us guide going forward? Because again, this is the first time Kaggle's done anything like this. I certainly enjoyed it. It seems like people enjoyed it, but we do like the data. All right. Yeah, and you're very welcome, Plunky. And believe me, I am considering the NLP challenge. I would very, very much like to do that. But we don't want to do something of like nobody's going to show up, right? So, all right, make this public. Yeah, and I will see you guys. And feel free to I mean, I'm on Kaggle every day because it's my job. So feel free to hit me up, and if you have any questions, just let me know. All right, thanks, guys. I will see you on Kaggle.